Hey guys, we're back. We're going to read chapter 26 of George's Secret Key to the Universe. George found out what Eric was talking about when he said to find his new book on the black holes. My difficult book made simple for Annie and George, version 3, it began. So here is actually what the beginning of the book looks like. So it's got a table of contents telling George where everything is. Section 1, what is a black hole? That's on page 2. Section 2, how is a black hole made? On page 3. Section 3, how can you see a black hole? Which is on page 4. Section 4, falling into a black hole. That's also on page 4. And section 5, getting out of a black hole, page 6. Section 1, what is a black hole? A black hole is a region where gravity is so strong that any light that tries to escape gets dragged back. Because nothing can travel faster than light, everything else will get dragged back too. So you can fall into a black hole and never get out again. A black hole has always been thought of as an ultimate prison from which there's no escape. Falling into a black hole is like falling over Niagara Falls. There's no way of getting back the same way you came. You're not going to go back up the waterfall. There's a little note on here that says, must mend my glasses. And there's a black hole that says, there's a light bulb and it's being pulled in. It's saying the light is being pulled in and the light bulb says, help. Both of those images are up at the top of this page. There's more, I'll show you more as we go. As more things, the edge of a black hole is called the horizon, kind of like the spot where the land and the sky meet. It is like the edge of a waterfall. If you are above the edge, you can get away if you paddle fast enough. But once you pass the edge, you are doomed. As more things fall into a black hole, it gets bigger and the horizon moves farther out. It is like feeding a pig. The more you feed it, the larger it gets. So as more things get in, it gets bigger. So let's see if we can see it. On here we have this little guy in a boat who is on the top of a waterfall. As he goes over, he'll be doomed. And then on the bottom, we have the pig getting bigger and bigger as he's fed food. Reminds me of Freddy. Section 2. How is a black hole made? To make a black hole, you need to squash a very large amount of matter into a very small space. Then the pull of gravity will be so strong that light will be dragged back, unable to escape. One way black holes are formed is when stars that have burned up their fuel explode like a giant hydrogen bombs, called supernovas. The explosion will drive off the outer layers of the star in a great expanding shell of gas, and it will push the central regions inward. If the star is more than a few times the size of our sun, a black hole will form. Much larger black holes are formed inside clusters and in the center of galaxies. These regions will contain black holes and neutron stars as well as ordinary stars. Collisions between black holes and the other objects will produce a growing black hole that swallows anything that comes too near it. Our own galaxy, the Milky Way, has at its center a black hole several times the mass of our sun. Okay, lots of images here. So this is them taking a whole bunch of things and squashing them into a little bit tiny space. It creates a really big gravity because its mass is so much. And then we have the exploding star, and the last one, the black hole, getting everything that comes close. Section 3. How can you see a black hole? The answer is you can't, because no light can get out of a black hole. It is like looking for a black cat in a black cellar. But you can detect a black hole by the way its gravity pulls on other things. We see stars that are orbiting something we can't see, but that we know can only be a black hole, right? They're being pulled closer. We also see disks of gas and dust rotating around a central object that we can't see, but we know can only be a black hole. Section 4. Falling into a black hole. You can fall into a black hole just as you can fall into the sun. If you fall in feet first, your feet will be nearer to the black hole than your head and will be pulled harder by the gravity of the black hole. So you will be stretched out lengthwise and squashed in sideways. The stretching and squeezing is weaker the bigger the black hole is. If you fall into a black hole made by a star only a few times the size of our sun, you will be torn apart and made into spaghetti before you even reach the black hole. But if you fall into a much bigger black hole, you will pass the horizon, the edge of the black hole, and the point of no return, without noticing anything particular. However, someone watching you fall in from a distance will never see you cross the horizon, because gravity warps time and space near a black hole. To them you will appear to slow down as you approach the horizon and get dimmer and dimmer. You get dimmer because the light you send out takes longer and longer to get away from the black hole. If you cross the horizon at 11 o'clock according to your wristwatch, someone looking at you would see the watch slow down and never quite reach 11 o'clock. Alright, we have lots of pictures. So he's shining a light. Then we have things going around the black hole. We can tell that it's there because something is going around it. Down on the bottom, he's actually got a list of things to do. It says must buy for conference, tea, milk, cookies, jelly donuts, sugar, napkins, ginger cookies. Must call Professor Zerfsgaff, remember she was the speaker. And then there's a picture of a normal astronaut black hole. Okay. Then we have an astronaut falling into a black hole. And he's stretched and squeezed, and here's the spaghetti right here. And then this is what somebody would see if somebody was falling into a black hole. These are things that are true. Black holes are true, and what they do is true, and if you fell into one, this is what it would look like, but people don't typically fall into them. So that part of it, they're just trying to explain it. Section 5, getting out of a black hole. People used to think that nothing could ever get out of a black hole. After all, that's why they were called black holes. Anything that fell into a black hole was thought to be lost and gone forever. Black holes would last until the end of time. They were eternal prisons from which there was no hope of escape. Doomed. But then it was discovered that this picture wasn't quite right. Tiny fluctuations in space and time meant, fluctuations means changes, that black holes couldn't be the perfect traps they were once thought. Instead, they would slowly leak particles in the form of Hawking radiation. The rate of leakage is slower the bigger the black hole is. The smaller a black hole gets, the quicker it evaporates. The Hawking radiation would cause black holes to gradually evaporate. The rate of evaporation, you guys know about this when you boil water and the water starts to evaporate and go in and become gas. That's kind of what he's talking about. Would be very slow at first, but it will speed up as the black hole gets smaller. Eventually, after billions and billions of years, the black hole will disappear. So black holes aren't eternal prisons after all. But what about their prisoners? The things that made the black hole or that fell in later. They will be recycled into energy and particles. But if you examine what comes out of the black hole very carefully, you can reconstruct, put back together what was inside. So the memory of what falls into a black hole is not lost forever, just for a very long time. So his conclusion is you can get out of a black hole. So this is all kind of an idea, not something we could actually do. So here's the prison. Here's the black hole gets smaller and smaller and smaller, so its rate of evaporation is faster, and then the guy getting out of the black hole. chapter 26. Oh, wait. There was a page back on page 234 that talks about a neutron star. So if you want to hear about neutron stars, we're on page 234. When stars much more massive than the sun run out of fuel, they usually give off all their outer layers in a giant explosion called a supernova. Such an explosion is so powerful and bright, it can outshine the light of billions and billions of stars put together. But sometimes not everything is expelled in such an explosion. Sometimes the core, the center of the star, can remain behind as a ball. After a supernova explosion, this remnant is very hot, around 180,000 degrees Fahrenheit. But there's no more nuclear reaction to keep it hot. Some remnants or pieces are so massive that under the influence of gravity, they collapse in on themselves until they are only a few dozen miles across. For this to happen, these remnants, pieces left over, need to have a mass that is between around 1.4 and 2.1 times the mass of the sun. Page 235. The pressure is so intense inside these balls that they become liquid inside, surrounded by a solid crust about a mile thick. The liquid is made of particles that normally remain inside the formed atoms, the neutrons. So these balls are called neutron stars. There are also other particles inside neutron stars, but they really consist mostly of neutrons. To create such a liquid on Earth is beyond our present technology. Stars like the sun do not explode in supernova, but become red giants whose remnants are not massive enough to shrink under their own gravity. These remnants are called white dwarfs. White dwarfs cool down over a period of billions of years until they are not hot anymore. Many neutron stars have been observed by modern telescopes. Since the cores of stars are made of the heaviest elements forged inside, stars, like iron, although white dwarfs can be quite small, about the size of the Earth. They are extremely heavy, about the mass of the sun. Last one. Star remnants that are less heavy than 1.4 times the mass of the sun become white dwarfs. Neutron stars are born from supernova remnants that have between 1.4 and 2.1 times the mass of the sun. Remnants more massive than 2.1 times the size of the sun never stop collapsing on themselves and become black holes. So I know some of this is really hard to understand, kind of interesting to have in your head, and then if something really catches your imagination, you can learn more about it or remember about it later on. Okay, so the end of chapter 26.